Okay, this is 11 August. Translating parabolas part 2, sliding left or right. So today we're going to be dealing with this part of the graph. So once again, just like always, we compare everything we do to the original graph. The original graph, the base graph, is a parabola that has original graph is a base graph, look like this, and we know the values of this. We know that whenever 0 goes in, 0 squared is 0. If I pick 1, 1 squared is 1. And if I pick negative 1, negative 1 squared, don't say negative 1, negative times negative is positive 1. There we go, so that's that one. When I put 2 in there, 2 squared is 4, 2 times 2 is 4. So that would be way up here. Negative 2 squared, negative times negative is positive 4. So, the normal graph looks like that. Okay, what we're going to be doing is we're going to be sliding it left and right. So that we're going to focus on inside the parentheses. So, my next equation, there's two things we can do. So let's just write them down here. And so we've got, here we go. So I can add a number inside the parentheses, or I can subtract a number inside the parentheses. One of these moves to the left, and the other one moves to the right. So what you're going to discover is things work differently inside the parentheses than you would expect. Yesterday when we were dealing with k, it made sense because when you added 3 it went up and subtracted 3 it went down. Well, today it's backwards. Inside the parentheses it's backwards. So x minus 3 actually moves things to the right. X plus 3 moves things to the left. So if you add a number inside, it doesn't have to be 3. If you add a number inside, it's going to move it to the left no matter what number you add. So I'm going to add a 7, add a 2, add a 1.5. Doesn't make any difference. You can add fractions or decimals. Same thing over here. If you subtract any number, if you subtract a half, then you're going to move it left. Excuse me, right. If you subtract a 7, you're going to move it right 7. So here we're subtracting 3. So I've got my graph right here. And what I notice whenever I do this, we can put the x and y just like before. When I put 0 in here, 0 minus 3 is negative 3. Alright? So what I'm doing is whenever I put 0 in, I get off my graph because 0 minus 3 is negative 3. Negative 3 squared is 9. Holy smokes! Look what happened. 1, 2, 3, 4, 5, 6, 7. It's way up here. My graph goes way up here. Right? So we don't want to start with 0 like we did here. What we're doing is we're saying the whole graph slides to the right 3. So that means if I started at 3, let's start at 3 here. let's get rid of this. There we go. We'll try again, huh? There we go. Alright. So I'm going to start at 3 because that's the starting place. 3, 0. 3 goes in. 3 minus 3 is 0. 0 comes out. Dot right there. So now, just like this one, if I go one to the right of the vertex, and one to the left of the vertex, that's where my parabola goes this way. So if I go to the right of the vertex, I'll put 4 here. 4 minus 3 is 1. 1 squared is 1. So when 4 goes in, 4 minus 3 is 1. 1 squared equals y. Y is 1. So that means over here, I'm right there. Well, what if I go on the other side? What if I go 2? 2 minus 3 is negative 1. Remember, negative 1 squared, negative times negative is positive 1. Holy smokes. There we go. So what if I go 2 to the right? That'd be 5. 5 minus 3 is 2. 2 squared is 4. So over here I'm going 1, 2, 4. And then back this way the same way. 1, 2, 3, 4. So that would be, if I was at 1, 1 minus, that's negative 2. Negative 2 times negative 2 is positive 4. Now my parabola goes like this. Woo-hoo-hoo, woo-hoo-hoo. In fact, remember the first place we found was 0, way up here. Right? It can keep on going. This goes up here too, all the way this way. Right? But you don't have to draw it that way forever. You can just put arrows knowing that it goes forever up. Right? Now then, so if this one moves right, this one moves to the left. So we will show you that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There we go. Now then, this one's going to move to the left, and like I said, I want to start with the bottom of the graph, so I'm going to use negative 3. Where can I write that? I'll put it right here. I'll make my little thing right here so we know we're not looking at that one anymore. So I'm going to start at negative 3. Why did I do that? Because negative 3 plus 3 is 0. There's nothing here. So 0 squared is y equals 0. So negative 3, 0. Then I go 1 to the right. I go up 1, just like here, over 1, up 1, over 2, up 4. Right? So the same thing is true here. If I go 1 to the right, that would be negative 2. So negative 2 plus this would be 1. Negative 2 plus 3 is 1. 1 squared is 1. If I go another one, I can go negative 1 plus 3. That's the same thing as saying 3 minus 1. That's 2. 2 squared is 4. Hallelujah. And then if we went all the way to 0, 0, that'd be 3. 3 squared is 9, so that's way up here somewhere, right? So we got 1/2 of our parabola, but the other half is the same way, because this goes over 1, up 1. This one has to go over 1, up 1. So when I pick negative 4, I've got negative 4 plus 3, that's negative 1. Negative 1 squared, 1. What if I put negative 5 in there? Negative 5 plus 3, it's like saying 3 minus 5. That'd be negative 2. Negative 2 times negative 2, positive 4, right there. And I could go negative 6, that'd be negative 3, that'd be 9, way up there too. So my parabola would look like this. So, whenever you add something inside the parabola, it moves to the left, and when you subtract something inside the parentheses, it moves to the right. Right? That's the end of part 2.